So hi guys, welcome back to the channel, and today we are going to solve bubble sort. So in this is a basic sorting algorithm in which we are giving an array and size, and what we have to do, we have to sort. So sort in ascending order means smallest elements come first, then then in this order highest elements come in the last. Like sorting of this is 1, 3, 4, 7, 9. So now how bubble sort algorithm works. So as the name suggests, bubble sort, so it means it says bubble, so it says the biggest elements are goes to the last part of the array, and the and you will see that gradually uh, all the smallest elements come in the front of the array, and all the last element in the last of the array, and array becomes sorted. So how this algorithm works, so let's see in this example. So we have given array 41397. So array is 41397, array size is 5. So this is array, and this is index is 0 1 2 3 4. So first what happened, index 0 and index 1, these compare. In the first iteration is compare which one is smaller. If arri and arri plus 1, if arri is greater than arri plus 1, then what we can say, these need to be swapped because all the greater elements are in the last part of the array, so these need to be swapped. So these are swapped. One comes 4. Then in the next, it's check 4 and 3, which one is greater. 4 is greater, so again swap. Then 4 and 9, which one is greater. 9, so there is nothing happen. Then 9 7, which one is greater. 9, so there is swap. Then yeah, then in next, and then this is first pass f1, and 9 goes to its correct position. 9 goes to its correct position. Now in the second pass, 1 and 3 are is correct position, so there is no need to swap. 3 and 4 are also correct, no need to swap. 4 and 7 are also correct, no need to swap. 7 goes its correct position. Then in next pass, 1 and 3 are is correct position, no need to swap. 3 and 4 correct position, no need to swap. So 4 goes correct position. Then in next, 1 and 3 are correct position, no need to swap. And 1 at correct position, 1 is 3 at correct position. Then this element are correct position, and this is also position. So sorting has done. Let's say some another example. Let's say 7 size of the array, and values are 12, 4, 2, 6, 7, 8, 8, 4, 3. Yeah, so we are running this. So now 12, 4, 2, 6, 7, 8, 3. So 12 goes 12 and 4. The starting of is 12 and 4. 12 is greater, so swap. Then 12 2 swap. Then 12 6 also swap. Then 12 7 swap. Then 12 8 swap. Then 12 3 swap. So in the first 12 goes in the correct position. Now in the next 4 2 swap. Then 4 6 not swap, because no need to swap because 4 is at the initial for 4 is smaller than 6, so it goes in the starting part of the array, and 6 goes end of the array. 6 7 no need to swap. 7 8 no need to swap. 8 3 need to swap, so it goes its correct position. Now to 4 no need. 4 6 no need. 7 3 need to swap, so 3 goes correct position, and 7 at correct position. Now 2 4 no need. 4 6 no need. 3 6 need. 6 goes correct position. Then 2 4 no need. 4 3 need. 4 goes correct position. Then 2 3 no need. 3 goes correct position, and further we can say that these are at correct position, so this is also at correct position, and the algorithm finishes. So now the coding part. So how this algorithm works. So what we are doing, we are running a loop. We are running a for loop which start from I equal to 0 till n, and there is another for loop which we are checking if arri greater than arr of this is greater or not. So there is 0, j less than n, also j plus plus, and j less than n minus I minus 1. Why? Because we say that if it's 0, then we have to check all the values. If I is 1, then we have to check these values, not this, because this is already sorted in the first iteration. So n minus I, we have to Also we have to check if ARR of j, if this element is greater than ARR of j plus 1, then what we can say, we need to swap. We need to swap due to j plus 1. If we use n minus I, then the last n become I become n minus 1, and it is become 1 in the last whatever I become n minus 1, so it's become n minus 1, so it become j is less than n minus I, so it's n minus I minus 1, and it's n minus I minus 1, it's become n minus I, and I is n, so it's become, this is going to the last part of the, it's n ARR of n, and it can't be usable, so if we use n minus I minus 1 for this case, and we have to swap this, and this will run perfectly fine. Let's see. Yeah, let's submit this. So yeah, problem solved successfully. Now we can also optimize this code if we in the first like we find that if array is already sorted, like if it's given 1 3 4 7 9, then the first iteration we can in the first iteration, if any node swap happens, then we can say that array is sorted, so we don't have to perform another iterations. So how we can show that? So I am making a bool swap variable, swap equal to I am saying false if no swapping is happen. If swapping happens, then we can say swap equal to 2. Because swap equal to true, and saying if swap equal to false, if swap equal to false, then you can say that you don't need to check another condition, just break through the loop. What this step will make sure that if array is already sorted, then the time complexity remain big of n, because if array is already sorted, then this will only take one only just iterate through the array, and once check if it is sorted, then swap false and break. So time plus big of n in best case if array is sorted, otherwise time complexity is big of n into n, big of n square. In the worst case, time complexity is big of n square, space complexity is big of 1. We not we are not using any space. So yeah, that's for the video. Bye.